Hey guys, it's Ms. Johnson, and I'm here to bring you the second half of section 8.1. Today we're going to talk more about how to interpret confidence levels. So we're just going to kick off a reminder of what that confidence interval is. So a confidence level C, it says to interpret a confidence level C, say, if we were to select many random samples from a population and construct a C% confidence interval using each sample, about C% of the intervals would capture the parameter. Okay, so there's a confidence interval and there's also a confidence level. Okay, so we're going to talk about a confidence interval, which we introduced yesterday, and today we're going to get into the confidence level part of it. So interpreting a confidence level. So we talked about that presidential election candidate A, candidate B question before yesterday in yesterday's notes. So in today's notes, now we're going to interpret the confidence level. So it says, based on this poll, the 95% confidence interval for the population proportion who favor candidate A is this. If we want to interpret that, we're looking at confidence level, which is a little bit different than confidence interval. Now, we're going to use the same percentage. We're going to talk about a 95% confidence level, okay? And here's what that interpretation would look like. It would say something along the lines of, if we were to select many random samples of registered voters and constructed the 95% confidence interval, for each sample, interval, for each sample, we are, or I should say about 95% of them would contain the true population proportion. Of voters who prefer candidate A. Population proportion prefer candidate A. Okay, so this gets into a little bit of the simulation stuff that we did back in chapter 5 and then again in chapter 6 when we talked about how if we repeat this process over and over and over and over again, if we keep pulling a sample, constructing a 95% confidence interval, pull another sample, construct a 95% confidence interval, pull another sample, and keep doing it and keep doing it and keep doing it over and over and over, we can also say that we are 95% confident that 95% of them will contain the population proportion. So we think that we will hit the mark 95% of the time. Okay, if you're constructing a 95% confidence interval, that means that you have a 95% confidence level if you continue to repeat that process. So here's just kind of a little picture of what that might look like. So it says once a particular confidence interval is calculated, its endpoints are fixed. And because the value of the parameter is also a constant, a particular confidence interval either includes the parameter or it doesn't. So if I look at all of these confidence intervals, so the theory here is that each one of these is a different confidence interval. The black confidence interval shows you what the statistic is, and it shows you where that confidence interval lies. So like this one, the confidence interval is a little bit higher. This one, the confidence interval is a little bit lower. But if I'm using this green line as my mu, Okay, that green line going down the middle is the mu, true population mean. In this case, they're looking at mean. So true population mean. There is one of them right here that does not cross over that true population mean. So our confidence level means that all of the ones that are in black that included the mean are where we were confident that that confidence interval included the true population proportion. It was only that one in red that did not include the parameter. Okay, so most of our confidence intervals included the parameter, but that one confidence interval did not include the parameter. And again, this all goes back to sampling variability. The fact that we're pulling a different sample of subjects, a different sample of subjects, a different sample of subjects, that's going to lead to a different confidence interval every single time. So the true way to get a good confidence level is to repeat that process over and over and over and over again. Okay, so be careful. It says the confidence level does not tell us the probability that a particular confidence interval captures the population parameter. It's not a probability question. It just tells us how many times our interval includes the mu. So how often does our confidence interval include the true population parameter, whatever the parameter is that you're looking at? Okay, here's another AP exam tip. It says on a given problem, you may be asked to interpret the confidence interval, the confidence level, or both. So be sure that you understand the difference. The confidence interval gives you a set of plausible values for the parameter. Confidence level describes the overall capture rate of this method if you were to repeat it over and over again. All right, so just decreasing the margin of error. So let's talk about margin of error again. So we've got this confidence interval, this confidence level that we're trying to hit, and that gives us a margin of error that tells us how wide our interval needs to be. So what happens here is, in general, we prefer an estimate with a small margin of error. The margin of error gets smaller when the confidence level decreases. So if we are only 80% confident that it captures our true population parameter, then our interval is going to be a lot smaller. Okay, we're only 80% confident that it's in this interval, but that gives us a smaller interval. So the confidence level went down, but our interval got smaller. Now, if you want to have a higher confidence level, that means that you have to widen your interval. So it just depends on what you're looking for. So this 95% confidence interval has a much wider interval, okay? Because we're 95% confident that it falls in there. We're only 80% confident that it falls in this top one. But look at how much smaller the interval is, okay? So again, decreasing the margin of error. Another way to decrease the margin of error is to increase your sample size. We've talked about this back in chapter 7 with sampling distribution. When you increase your sample size, you decrease your sampling variability, okay? You have a smaller standard deviation. So if we increase our sample size, that means that our margin of error is going to be smaller because we decrease our standard deviation. Remember when we had the standard deviation where we had the square root of n in the bottom? And if we wanted to cut our standard deviation in half, we needed to multiply n times 4 because the square root of 4 is 2. And so then that would cut our standard deviation in half. So think back to that scenario. You increase your sample size, you decrease your variability, decrease your standard deviation, okay? All right, so one more slight error or slight caution on this. It says the margin of error does not account for any sources of bias. So be careful. The margin of error does not look for biases. So if you're using a sample that has any bias in it, your margin of error is still going to calculate, but do you really want to use that sample if it has bias with it? So just be careful with that. All right, so what else affects the margin of error? It says for a normal sampling distribution extending about 2 standard deviations in each direction from the statistic produces a 95% confidence interval. Go back to that normal curve. Remember the 68, the 95, and then the 99.7. That was that empirical rule, 68%, and then 95% was within 2, and then the 99.7 was within 3, okay? So if you think about the empirical rule, then it says for normal sampling distribution, extend 3 standard deviations, and you're at a 99.7 confidence interval. Okay, so this is when you're looking at normal distributions. It says the more general formula for confidence interval is your statistic plus or minus your critical value times the standard deviation of the statistic. Okay, so that's how we're going to be calculating our confidence intervals. The critical value is a multiplier that makes the interval wide enough to have the stated capture rate. All right, so what else affects a margin of error? It says, as we're going to look at an example here. As part of a project about response bias, Ellery surveyed a random sample of 25 students from her school. One of the students in the survey required students to state their GPA out loud. Okay. Based on the responses, Ellery said that she was 90% confident that the interval from 3.14 to 3.52 captures the mean GPA for all students at her school. Okay, so let's unpack this a little bit. What could possibly be wrong with this scenario? So in part A, it says explain what would happen to the length of the interval if the confidence level was increased to 99%. So if you increase your confidence level, that also means that it increases your margin of error, which makes your confidence interval wider. So increasing your confidence level also increases your margin of error. Which then increases your confidence interval, or I should say widen. So that's, in some people's opinion, a problem. You don't necessarily want a super wide confidence interval. But if you have a wider confidence interval, then you're usually more confident that the value is actually in there, which kind of makes sense. Okay, so let's look at part B. It says, how would a 90% confidence interval based on a sample of 200 compared to a 90% confidence interval based on the original sample? Okay, so the original sample was n equals 25. Now, if we go to n equals 200, what happens? Well, if you increase your sample size from 25 to 200, that is going to have a good effect on your confidence interval. Increasing the sample size, from n, oh my gosh, I can't write m's today, from n equals 25 to n equals 200, will reduce, will shrink or reduce the margin of error, which will then make your confidence interval narrower. Okay, so increasing your confidence level in part A makes your confidence interval wider. But increasing your sample size in part B makes your confidence interval narrower. So that's good. Okay, now let's talk about part C. In part C, it says, describe one potential source of bias in Ellery's study that is not accounted for by the margin of error. So the margin of error is not going to find the biases, okay? Let's go back to the original question. As part of a project about response bias, Ellery surveyed a random sample of 25 students from her school. One of the questions in the survey required students to state their GPA aloud. Now, I don't know about you, but anytime someone's asking me to state something as sensitive as my GPA out loud, Somebody who's not entirely proud of their GPA may not actually give the honest truth. Okay, so if we are asking them to respond out loud, that's going to promote, or not promote, but it's going to be tempting for people to not be truthful. If they're tempted to lie or misreport their GPA, then that means that our population mean will likely be inflated. We're going to look at, because they're probably going to say that their GPA is maybe a little bit better than what it actually is. So here's how I would maybe say something about Part C. It's likely that students reporting their GPA out loud may not, or may lie, I should say, may lie about the actual value, therefore inflating the sample mean, which also makes which means the population mean is likely lower. Okay, so if you're going to put in a bias like that, the confidence interval is still going to calculate. The margin of error is still going to calculate. Margin of error is not going to account for that bias. So you have to be really careful about calculating your confidence interval if you're using a sample that had bias in its reporting methods. All right, so that takes us to the end of section 8.1. So this is just an introduction of confidence intervals and confidence levels. What are they? What are we looking at? What are they finding for us? We're going to get into actually calculating these things in section 8.2. So stay tuned for that, and thanks for tuning in.